Hello students, welcome to the next lecture of the Boolean Algebra. In the last lecture we had seen lots of Boolean operations, their logic gate symbols, circuits and truth tables also. So let's continue with the Boolean logic today. Today we will study about some important terms into the Boolean algebra, from which the two are sum of the products and product of the sum forms, which are also called as the SOP and POS forms. So what is the SOP form? Basically SOP form is the sum of products of the variables. So if you can see in the first example, so there are some products, let's say x dot z. So this is x dot z dash, x dot yz bar, xy bar z. So these are the products of the variables and they are written in the form that all these products have been summed together. So this is the sum. So such type of form is known as the sum of products, that is SOP. Now just opposite to this, in the second example we can also see that there are three variables a, b and c, product of a and b, c, product of a and c, product of a dash b, c dash, and all these products have been summed, written in the sum form. So this is the SOP form. And one thing to be noted, that in a sum of product expression, one complementation sign cannot cover more than one variable. For example, we cannot have the product of type like this x, y, z. Whole complementation cannot be there. Even a, b whole complement cannot be there. The complement sign will be only with a single variable. If you'll see in this example, so this is not yz whole complement. So this is y complement dot z complement. So this is the point to be noted into the sum of product form. Just opposite to this, we have product of sum forms. Like here we have a product of sum forms. Uh, this is the sum of x plus y. This is the sum of x plus y, and both these are product together. In the second case also, the sum x plus z, the sum x plus y bar plus z, and both the sums have been producted together. So this is the sum of so this is the product of sum, that is POS form. Now let's talk about the normal forms. We have two normal forms uh, on the Boolean algebra. One is the min term, another is the max term. A min term of n variables is a product of n literals in which each variable appears exactly once in either true or complemented form, but not in both the forms. So exactly once, and either in a complemented form or in a normal form, but not in the both forms. So in this you can see, so these are the main terms. If you'll see, this is x and y. If x is there, then x complement cannot be there. If y is there, then y complement cannot be there. In the second case, you can see x bar y. If x bar is here, then x cannot be here. If y is here, then y bar cannot be here. You can see the last example, x bar dot y bar. Whenever x bar is here, x cannot be here, and y bar is here, then y cannot be here. So this is the main term. Max term, max term of n variable, max term, a max term of n variable is a sum of n literals in which each variable appears exactly once, either true or complicated form, but not in both. So this is the very similar definition as we have seen into the main term. The only difference is that in the main term we had the product of variables, and in the max term we have sum of variables, sum of literals. Excuse me. So rest all the definitions are similar. As you can see here, the examples are given where the variables or literals are summed together. In the first example, it is x plus y. If x is there, x bar cannot be here. If y is here, y bar cannot be there. As in the third example, x plus y bar. If x is here, x bar cannot be here. If y bar is here, y cannot be here. X bar plus y bar. If x bar is here, x cannot be here. Y bar here, y cannot be here. So these are the sum of literals. So this is your max terms. Now let's go further to our next definitions, to the next thing. Now let's talk about the canonical form. Okay. Now what we mean by the canonical form, a Boolean function when expressed as a sum of all to the power n minterms of n variables is called the canonical minterm expansion or complete minterm expansion, and also known as the disjunction normal form. Similarly, if we'll replace this minterm with the max term, that means if a function when expressed as a product of all 2 to the power n max terms of n variables, then it is called as complete conjunctive normal form. So we have two normal forms. One is complete disjunction normal form, and the other is complete conjunction normal form. The difference is that in the first, the complete disjunction, the expression is the sum. Mind it, the expression is the sum of all 2 to the power n main terms. So here two things are important, that the sum of all 2 to the power n main terms of a variable, this is complete disjunction normal form. And into the second thing, product of all 2 to the power n max terms, this is known as the complete conjunctive normal form. So now the complete minterm expansion in two variables, for example x and y, this is given by complete minterm expansion of two variables x and y. So we can see that what are the all combinations of x and y can be. So if we'll see, then one can be x dot y, other can be x y dot, next is x dot y, and third is x bar y bar. Sorry, these are all bars. So these are all the main terms of the two given variables x and y, and when we sum all these main terms together, it becomes complete main term expansion. Right, I hope you have understood. Let's consider another example. If we have two variables, let's say a and b, so what are the all possible min terms for a and b? That is, yes, a dot b, a dot b bar, b bar dot a, and a bar dot b bar. So these are all possible min terms, and when we sum all these possible min terms, we get the complete min term expansion of the two variables a and b. I hope you have understood what is here the complete expansion. Now this complete expansion can be reduced, and to reduce we will be using the laws of the Boolean algebra. For example, so this is an example have been given where we have taken let's take this first two terms. We have taken x as common. Now y plus y bar, obviously we know by the law of complement that y plus y bar is equal to 1. Similarly, on the second side, x bar plus y bar, we can take x bar as common and by the complement law, y plus y bar will become 1. Then by the law of identity, x dot 1 will be x, and x bar dot 1 will be x bar. And finally again, by the law of complement, we have x plus x bar as 1. So this is the reduced expression. So we can reduce any such expression to the minimum form. That is called as the reduction or simplification. So we can also prove these canonical forms with the help of the truth table. We can make the truth table and create the expressions also. Let's say this example. Consider a truth table and find out the corresponding Boolean expression in sum of min terms and product of max terms. So just by the help of this table, we need to find the sum of midterms and product of max terms. So let's see. We have three variables x, y, and z. For the three variables, we will have 2 to the power 3, that is 8 set of combinations. Obviously we can see the first row 0 0 0, the second row 0 0 1, the third row 0 1 0, the fourth row 0 1 1, and so on. Now what will be the output y, that is the resultant. So the first case it is 1 1 1 0 1 1 and 0 and 0. So this is the truth table has been given here with some values. Now we'll have to find out the corresponding canonical min term and the max term. So corresponding to every entry of 1, if we'll take where the output is 1, we can see that this is with the first, second, third, fifth and sixth rows. So we have first, second, third, fifth and sixth rows. We can find out the min terms. From the first row we can see it is from the first row, if we'll see, this is x bar, obviously 0 0 is indicated for the false, that is the complement, y bar and z bar. So we have got the first first expression, first variable product is as x bar, y bar, z bar. Next we will get x bar, y bar, z. Okay, next is x bar, y, z bar. Similarly, next is x, y bar, z bar. So similar way we can find all the values where the output is 1. So we can see we have these all values we have calculated from the truth table. Now just to find out the SOP, we need to sum all these products together. So if we'll sum all these products together, so this is our final result. F is equal to x bar, y bar, z bar plus x bar, y bar, z plus and so on. So this is the sum of all products. Now let's talk about the second thing, that is the product of all sums, where we'll find all the 0 entries as the output column. So if we'll see that this is the 4th row, 7th row and 8th row only. So we have only these 3 rows, 4th, 7th and 8th, from where we'll get the values. Let's talk about the what are the values. In the 4th row, this is x bar, this is y and this is z. 7th row, this is x, y and z bar, x, y and z. So we have 3 expressions here. Already these expressions will be written as in the form of sum. So x plus y bar plus z bar, x bar plus y bar plus z, and last one is this. So these are the sum of the variables. Now these can be written as product. So this is the resultant POS, product of sums. So I hope you have understood the method of finding with the help of the truth table. If not, you can replay the video. You can go back and play it again and again and try to understand. And otherwise you can have, if you have any questions, feel free to ask me the question. Now the next method, let's talk about the next method of finding the SOP and POS is the algebraic method. So let's talk the algebraic method with the help of an example. It is given, let's say the function is given f of x, y and z, where it is given as x plus y bar z, and you have to represent it in a sum of min terms. Sum of min terms. So now we have 3 variables. So the working rule is we have one missing variable in this, that is y. So we will begin with the adding this y variable into the expression. So we can use the property of complement, that a plus a bar is always 1. So we can add as we can write x as x dot y plus y bar, because y plus y bar is 1 and x dot 1 is always 1. So now this can be expanded by the help of the distributed theorem, xy plus xy bar. Now still missing the third variable into this. We have a third missing variable. So again we will use that theorem of complement. So z plus z bar and z plus z bar into both, and then again we'll expand, and we got this xyz plus xyz bar plus xyz and xy bar z bar. So this is the expansion. Now in the second term, which was y bar z, if you'll see, this is the second term. In the second term we have only one missing term, that is x. So we'll add x here, and just to add x, we will again be using the complement theorem, and we'll multiply it with x plus x bar. So on expansion we have got x y bar z plus x bar y bar and z. Now finally joining these two RHS and removing the common attributes from this. So we have got this uh, x y z plus x y z bar plus x y bar z plus x y bar z bar plus x bar y bar z bar. So this is how this can be achieved, just by eliminating the common variables again and again. If we'll see that what is the which is the common variable, do we have? Yes, we have these two common products is x y bar z and x y bar z. In this, in both the expressions we have this, so it will be written only once. So now uh, this is the final sum of products for the given function. I hope you have understood. Similarly, this, let's take the another example, that we will express this as a product of max term. In the last example we have seen as a sum of min terms. Now we'll take as a product of max terms. So let's talk about the approach. The function is a, b and c, then it is written as ab plus a bar c. So again this will be distributed ab plus a bar and ab plus c. So we have distributed using the distributive property. Again let me recall this: a b plus a bar c is distributed by this ab plus a bar dot ab plus c. If you have not seen the distributive property, you can go to the previous lecture and see the distribution. Now this statement is again distributed, this ab plus a bar. So this is a plus a bar, b plus a bar, distribution of this first term, and distribution of this second term will be a plus c and b plus c. Now by the complement law, a plus a bar will be 1. So we have left with b plus a bar, a plus c and b plus c. So now we'll see that each sum term is missing one variable. So in this, let's say into the first term, we have the first term as b plus a. So we are missing c. In this we are missing b, and in this we are missing a. So in all these we'll have to apply the theorem of complement. So let's see. For the first, we have applied the theorem of complement, C dot C bar. In this, B dot B bar. In the last, A dot A bar. And then we'll distribute this with the help of the distributive theorem, and we have got these results. Now removing the common terms that are appearing more than once, if we'll see, do we have any common terms in this? Do we have any common term? A b bar plus c. Yes, we have a plus b plus c. So a plus b plus c and a plus b plus c. So we have this common term. We will eliminate this and write it only once. So now this is the final product of sum, that is product of max terms. So this is how we can perform with the help of the truth table, and as well as with the help of the algebraic methods. I hope you have understood. For any query or any questions, feel free to ask. Thank you so much for the day.